packed presentation, so Jonas just moved over.
Hi.
Apparently, there's quite a few VO people here in town, but they don't know about that.
Yeah, they all are remote, so they don't want to go to the office. I'm the only guy who wants to. So.
All right.
Cool. All right. Thank you very much. So, like Matt said, I'm Jonas. I'm the engineering manager at DigitalOcean. I've been with the company for a little over 4 years now. Started when we were 5 people. We're a little over 300 now. Things have changed quite a bit since then. And so this is sort of a part of a story, or basically this is a culmination of the journey of that 4 years and how we've evolved some of the systems, some of the ideas, some of the things that we do internally within DigitalOcean. And so, as this is a Kubernetes meetup, you can probably guess that it's about Kubernetes. But this is a story of how we are internally consuming or using and making Kubernetes available to internal users within DigitalOcean, so developers and folks that need to deploy just about anything. So let's start with this little thing that I put up here. So in my opinion, operationalizing software is really hard. It's one of those things where we write software and then we throw it over the wall to somebody else and they manage it. That's all good. Now, as we all know, as users of Kubernetes, Kubernetes actually makes this fairly easy. But there's still, so a lot of people like to think of Kubernetes as a platform. And I'm one of the people who actually thinks of it as more of like a framework that you end up building your platform on top of. And so, while Kubernetes does provide a lot of things out of the box, I think there's quite a bit more that you will still need on your deployment of it to make it really a platform. And so, this story sort of focuses on how we've evolved operations internally within our company throughout the past, let's say, 3.5, 4 years. So I'm hoping that everyone knows what DigitalOcean is, but in case you don't, DigitalOcean is a cloud provider for developers. We're based out of New York, but over half of the company is actually remote, and we actually have a number of us here in the Denver area. And actually, I have to mention this since we just announced it today. We have an early access program for our object storage product. So in case you're interested in that kind of stuff, you should sign up. But we are basically a well-curated set of primitives akin to some of those similar ones that you could find in other platforms like Google Cloud or Amazon or Microsoft Azure, Rackspace, and so on and so forth. So this, our journey starts at the logical place called beginning. So sort of the, where we start is when I basically joined in early 2013, where you would, the common theme of how we were thinking about operations was, what is operations even? Now, DigitalOcean actually came out of a hosting, like a managed hosting provider. So we had a little bit of an idea of what operations meant, but it was very traditional operations, sort of your traditional sysadmin type of stuff. Now, a little later in that year, we sort of evolved our thinking. We started looking around like what other people are doing, what are some of the companies in the cutting edge doing, and so we thought about doing embedded operations. So we hired a bunch of people that were sort of what you would call today DevOps, and then embedded them with all the software engineering teams. And that was sort of a good progression, but it wasn't really a good way for us to scale, because this talent is very hard to find. If you've ever tried to hire DevOps engineers, you'll probably find that it's actually, the competition for that talent is very hard, and the term is so muddled that it's kind of hard to distinguish actually what you need and really distill that skill set down. So then, sort of early 2014, bless you, we ended up centralizing our operations function. So taking all of our DevOps out of those teams and putting them together into a centralized team. And we did that so that we could have a single dedicated team that was sort of providing a self-service, with the idea that they would be providing a self-service for all the developer teams. Now, there were some problems with that, in that we were able to hire our engineering team out much more quickly than we were able to hire out our operations team. And so, in early 2015, we started evolving this thinking to more of a sort of an operations as a service type of model, where we wanted these teams to basically build out services that every engineering team could consume, and they would basically set out the practices and patterns, but they were not directly involved in making all that work happen. And so they're kind of more of like an advisor of sorts. But very quickly we learned that the tooling that we had in place wasn't something that the development teams were super keen on taking on. And so finally, we towards the sort of mid to tail end of 2015, we arrived at this the model that, or the term that I guess the CTO of Amazon coined, you build it, you run it. And so we started thinking about, like, how do we make all of our developer teams actually fully capable of owning the full stack of or full scope of their service and everything that's related to that. And so that was sort of the point at which we started looking around for tooling, because we knew that the existing tooling that we had in place wasn't really working. Similar to or while we're doing this evolving of our operations, I think it's important to point out that the architecture that was powering the company or the product that we were providing was evolving as well. So we started out in early 2013 by having with 2 monoliths, and so we had what we would lovingly call the front end and the back end, pretty standard stuff. But then as we progressed through the year, we started breaking the front end up into more components that were sort of logically responsible for the different operations. So API, control panel, administration, and we still had a backend because everything would basically interact with the backend. Now, sometime in early 2014, we had some teams that were experimenting with this notion of services, or things we know now as microservices. And we're seeing good results out of that, but what we're also recognizing is that the tooling we had in place at the time wasn't really allowing us to keep evolving the stack as quickly as we liked. And so sort of once we got to the tail end of that year, we were we had had enough time to really build up the tooling internally to be able to support this sort of rapid iteration on services and spinning out things very quickly. So we decided that we would start putting everything out as a service now instead of building it into the monolith. It would basically just be spun out as a service if we could. There were still some things that we sort of baked into the monolith, but for the most part, any new project, any new product was built out from the ground up as a service itself. And sorry, go ahead. So, I mean, in our case, the everything that powered the underlying VM infrastructure was essentially like a monolith. So it was deployed in 2 instances on our sort of the control plane, and then the hypervisor layer was deployed separately, but it was basically all the same monolith. So that was a little bit difficult to evolve because there was increasing number of engineers working on that same code base, and sometimes changes you made in one place might affect another place that you were sort of unintentionally impacting, even though they were not at all related. So I found this graphic, which was very indicative of, or very indicative of basically what the theory we thought was going into this era of automation, bringing in all this configuration management tooling and really investing in making the patterns and everything working. What we realized is, we would now that we're spinning out these small services, they might take like 2 weeks to build and spin out. We would spend another week operationalizing that service to get it up and running. And as you can imagine, that sort of fixed overhead per service was not really sustainable. As we were driving the cost of building an individual service down, the operationalizing of that service, that overhead stayed the same. We just weren't able to make that overhead go down as quickly as we could on making the service, building a service go down, or the cost of building a service go down rather. So we got to a point in mid to late 2015 where we're thinking about, all right, what can we do? Like, how can we get out of this situation? So obviously we could have just done nothing. That we could have just kept going the way we were and just kept paying higher and higher premiums for the services that we're building. We could have hired more dedicated operations, or actually had a dedicated operations function whose sole responsibility was to take in services and spin it out into production, sort of your traditional operations function. We could have made more investment, or tried to make more investment into the tooling that we had, the configuration management tools, to make them more consumable for the engineers and make them scale with the sort of number of services that we're spinning out. Or, you know, we could just start looking for other tools because we were at a point where we weren't super happy with what we had. And so, you know, the obvious answer is we went to look for other tools. Otherwise, I wouldn't be talking about it. So what we started out with is thinking about what are we actually looking for in this tool, because we had gotten a lot of we had a couple years of experience under our belts from the configuration management tools that we had adopted, which had definitely helped us move faster from the tooling that we had before, which is to say, not much. But the reality is that they weren't still helping us move as quickly as possible. So we started thinking about, sort of amongst our team, we're thinking about what do we need to do to, or what are we looking for in this potential solution or tool that we're going to adopt. And so community was one of the things that we had actually been really happy with in our existing tool, and we had a community that we could reach out to, and they were actually really helpful in sort of getting practices and patterns laid out and things like that. So we wanted to maintain that. We were really conscious of the fact that there needs to be a large community, strong community, and an ecosystem around it. It can't be just centered around a single company, because we had seen the single company thing not really work out so well in a few instances. You know, for us, because we were a group of software engineers trying to solve an operations problem, we naturally gravitated towards having APIs for this. Like, this is, you know, we had previously not had APIs, we had DSLs, and that we weren't super happy with that, so we wanted a way to basically automate it by writing code, rather than scaling ourselves by writing code that would generate code, I guess, which was not a good way to go. We were coming to the realization, and we had been using containers for quite a while, so we were coming to the realization that containers were really the way to go. Containers our testing infrastructure had been running in containers since the beginning of 2014, late 2013. So we had a lot of comfort around using containers and defining and building containers. So we thought that would be a good way to go forward, especially as we had a number of issues around managing the dependencies for any given application that we had. Because our stack is, you know, we have Perl, we have Ruby, we have JavaScript, we have Go. I'm sure we have Python. We have probably other things that I don't even know about, and that's good because we have containers now. And then finally, the thing that we wanted to make sure was that this system that we're going to bring in was production grade. And what that means is that there had to be other people that were in production with it. We did not want to be the first people with it, being the story of like, hey, DigitalOcean went to production with X, and that is not the story we wanted to tell. So, you know, these were sort of the criteria that we were looking for out of the gate. This is how we were sort of evaluating different projects and tools. Now, at the time, there were a bunch of options, and now there's probably way more. So we looked at Nomad, which was really early stages at the time. It was probably 0.1. It had just been released on Hacker News. Somebody's like, we should check that out. It's like, great. We looked at Aurora, and we came to the conclusion that it was a little bit difficult to get up and running. If you've ever used the Scala tooling and you're not a Scala developer, it can be a little bit intimidating. We looked at Marathon, because that seemed like the most prominent as a framework at the time, and it seemed like it was pretty good. We kicked the tires quite a bit, actually, with Marathon. And we looked at Docker Swarm, and I forget if this was right around the time that Docker Swarm went through its second rewrite or the first rewrite. And so we kind of decided that wasn't maybe the direction to go. Now, obviously, this being a Kubernetes meetup, it's probably not very hard to guess what we went with. Otherwise, I'd be pulling a fast one on you guys. So something that we're thinking about more, is based on taking the learnings that we had from our configuration management tools. We wanted to sort of provide a more well-curated solution. So we were sort of thinking about what would that look like? What are the aspects of this solution that we should really refine and hone in on? And one of the paramount things that we really wanted to focus on is user experience. So the thing that we really wanted to, the first class thing that we want to have is a well-curated user experience. So you shouldn't have to learn everything about the tool. Now, if you know Kubernetes, you know there's a lot of moving pieces to it. And so one of the things we did is actually look at really hard about like what are the things that are essential for getting the job done. And then there's a lot of other like tangents that you could go on and that are super interesting, but not probably useful if you're trying to productionize a service. We started out for the sake of simplicity, focusing on stateless services. At the time, Kubernetes was around 1.0, so there wasn't really much of a story around stateful services, and frankly, probably 90% of our services are stateless, so it was actually fine for that being the focus. And then finally, one of the things that we really wanted to make sure is that the deployment of a given piece of software, they would be declarative, so people wouldn't be telling the system how to do its job, but they would just tell the system what do we want at the end of it. And so those were sort of the set of guiding principles that we set out with and that we're using on top of the criteria that we were using for picking the tool. And so what we end up doing is we actually created a layer of abstraction on top of Kubernetes that we call DOCC. So it started out being called DigitalOcean Control Center, and very quickly everyone's like, no, we're just going to call it DOCC. So it's basically just a command line tool for deploying stateless containerized applications. So we sort of liked some of the ideas in Kubernetes and other systems, and so we started out by having essentially a manifest which describes your application, very much in the same way that the YAML files in Kubernetes describe yours, except ours is just JSON, because why not? So you basically tell us what your runtime requirements are for the system, and that I'll show you an example a little bit later to kind of walk through those. One of the things that we wanted to do with this manifest, and one of the reasons why we established this layer of abstraction was that we wanted to integrate you with the existing systems that we had. We had built a lot of systems that were tied together with the existing tooling that we had on the configuration management side, and there are a lot of sort of conventions that people were comfortable with. And so we wanted to make sure that we can carry that same level of integration forward. And so what we did is we actually made a lot of that sort of a first-class component of this idea of manifest that we built in. And I'll talk about that in a little bit. And then finally, one of the things we wanted to make sure is that we would establish ownership. And so we would know if a service is misbehaving, we know who to go to talk about that. Because when you're getting to a point where you have hundreds of services, it's pretty easy to get lost, or it's pretty easy to lose track of who owns what, who's responsible for what. Especially as maybe you move teams around, and maybe you move responsibilities around. It needs to be really easy to update the notion of accountability. So you need to be able to find owners and ping them like, hey, did you know your service here hasn't been working for a week or has been misbehaving or whatever. And that has been really useful for us. That has proven to be really useful for us in terms of like communicating with teams about their services and the changes we've been making to the system. Sure, go ahead. Yep. Yep. So, yep. So, sorry. Yeah. So the question was, if I understand you correctly, did we provide a self-service way for people to deploy their application? And the answer is yes. So essentially, this is an example of the manifest that you would have to provide. And so this is very simply, it's KubeCon 2017, scale 3. And much of this will look very familiar to you if you're familiar with Kubernetes, because we do bleed some of the underlying abstraction through, mostly because we agree with a lot of the things that Kubernetes does well. And so in here, you'll see application, which is the name of the application, very simple. Scale, how many instances of that do you want running at all times? What containers make up the application? Since we have the ability to have more than one container working together in a pod, we allow people to say like, hey, this container has this sidecar, for example, for X, Y, or Z, and they can put that in here, and off they go. And they'll say like, here's my image for running it. Here's the version of that image to run. And then you'll see the maintainer. So in this case, it's me. which we don't encourage. We actually prefer teams over people for maintainers because team scale, people do not. Yeah, exactly. And so with this alone, you can actually deploy this saying docc create, give it this file, and it'll push it up, and you will have an application running. And so one of the things you'll hopefully notice is that, well, minus the JSON sort of syntax, this is actually quite little in terms of like what you have to define in order to get a thing up and running. And so one of the goals that we had for this is that we would not require people to give us all the fields or all the necessary, all the values. Like we could use a lot of defaults, and we would try to be intelligent about sort of making things up for you as you go. So you could evolve this, and with evolving it, you'll get more and more features out of the box. And I'll actually walk through an example of this. So with that JSON file, what happens underneath the hood is we'll actually create a deployment for you. We start out with replication, what are they called? Replication controllers? Not replica sets. The previous iteration of that, which I now forget. But we now create just a deployment for you, which points to a replica set, which creates a set of pods. And actually, one of the things that we were able to do, because we have the abstraction layers, when Kubernetes 1.1 brought in the beta deployments, we actually changed the underlying implementation away from I forget what they're called. Yeah, replication controllers to deployments. And none of our users actually noticed anything. They just kept running. Their apps were just running, and we were able to evolve the underlying implementation. And so now, if we wanted to say expose this service to the world, because it's not really useful running it all by itself in a cluster without any ports, you just say expose port 8080. And what that does is it'll define a service for your deployment or your pods, and that's the only thing you need to define, but it's now available within the cluster for you, which is pretty neat in my opinion, because it's a very small change, but it actually has a quite significant impact within the cluster. Now, obviously, you probably don't have all of your apps within a single cluster, so if you want to expose it externally, what we have is a section called Ingresses. Again, very similar to Kubernetes, but in here you just say, I want to use this. I want to use the URL kubecon-2017 HTTP and point that to port 8080 on my deployment. This scheme here means that I don't want an automated TLS set up for me. It just means like I can use regular port 80 HTTP. And so this will automatically create an ingress for you that points to your service and now allows your service to be reached from the outside of the cluster. And actually nowadays, what we also do is we automatically configure our internal DNS to point to that ingress so that your application is immediately available within our internal network, and you can just you can expose that immediately. This has been very helpful for us when we do things like hackathons, when people work on prototypes. It's super easy to get a service up and running, available in the network. You can play with it if you have like a new concept that you're working on and you're not super sure. So this is very low barrier to entry in terms of getting a thing up and running. Obviously, I skipped over the step where you have to create a Docker file, and it's arguable that we could probably automate that away entirely as well, but we haven't so far. But it's still like it's not a lot of work. You can probably do all this within an hour and you're up and running. Whereas before it might take you, let's say, a week to get to this point. Hopefully not, but you know. So now one of the cool new features that we released fairly recently is we have a thing called Auto TLS. And so what that does is we have an internal CA, and all you can say is I want a TLS certificate, and you say, hey, my ingress is now TLS, and now all the traffic that hits your that comes from other services will be encrypted, and so it'll be end-to-end encrypted from the ingress down to your pod, basically. And we've also built some library functionality that actually pulls this certificate automatically for you. It's provided by Vault, so when it needs to be renewed, it automatically pulls a new cert and either hot reloads your application or sorry. Yeah, we underneath we use HashiCorp's Vault to provide the automation. So we have another component that we just tie into the cluster service. And so in this case, you will see we have actually a sort of a custom third-party resource called certificate, which is what actually gets generated, and that then creates a secret that then gets mounted into your pods, and every single one of them has the appropriate credentials available, and already when it comes up, it's already there, and you don't have to worry about it, which is pretty neat. So, you know, this is obviously a lot of stuff that we do out of the box, but there are some requirements to make this actually work. We sort of looked around, and 12 factors was sort of the most common thing. Cloud Foundry, Heroku, all these guys do it. Days does it also. And so we went with that, but we didn't follow sort of rigorously all the 12 factors. We're kind of like 12 factor-ish. We found that helps with the conversation with engineers when somebody new starts, and they usually know about 12 factors. It's easy to say, like, you know, make your application 12 factor configured. Now, we've also made that a lot easier because we have a lot of libraries that sort of automatically configure your application out of the box. Like, they assume certain environment variables that our system provides you, and they will just consume that automatically. So you don't actually have to configure a lot of this stuff, but this is more to kind of communicate that if you need to change configuration for your application, it's actually, you know, it's assumed to be in environment variables or sometimes in secrets, but mostly environment variables. Your applications need to be horizontally scalable, meaning that it can die at any time. It's too bad, but that's how it is. Kubernetes might decide that you're on a bad node. We might decide you're on a bad node. Kubernetes might decide that you're using too much CPU or other resources and kill you and move you elsewhere. Things happen. You know, this is the cloud. Too bad. So that's one of the big requirements we had is like anything you build needs to be able to sort of handle that kind of situation. If you need a locking service, you should use one, things like that. They're just assumptions that we've baked into this because we don't want to be babysitting people's services. That's not the reality we live in. We're a cloud provider. We have to be cloud native ourselves, so to speak. And then, like I mentioned earlier, we are stateless right now. When we started, there wasn't really any sort of stateful support. Now things are obviously getting better, so that's something we're definitely reevaluating. And we have a lot of interest in that internally, so we'll see where we go in the next 6 months. And like I said earlier, we sort of found in practice that 90 to 95% of our applications are actually safe, are stateless. What are the top stateless applications? So all of them are internal applications. You wouldn't know them because they're internal services that provide us something. But our API, our control panel are two good examples of something that is a stateless application running on top of this. So pretty much, I should say everything, but a good chunk of the services that power DigitalOcean today are stateless and are running on top of this platform. Sure, go ahead. Mm-hmm. Sure. So do we provide a control mechanism? And sure. Yeah. So we don't have any sort of an auto scaling component built into this yet. Again, another thing that we're sort of evaluating. But so a lot of the sort of out-of-box autoscalers aren't super useful for the kinds of applications we deploy on top of this. So we need to develop sort of custom metrics-based autoscalers. Like the horizontal pod autoscaler, if I remember correctly, it looks at only things like CPU. And if your application is not CPU bound, for example, that doesn't really matter. So we don't have sort of any sort of autoscaling, if that's what you mean. Scale out, sure. So to scale out, you can just say, hey, I need more instances. There's literally one field that you change, and it will give you more instances. And we have one of these clusters deployed, at least one cluster deployed in every single one of our data centers, sometimes more than one. So if you need to, let's say, have your service running across all of our, like globally, you have a cluster for every single data center. And so that's really easy to sort of scale out to be globally available as well. So you might be wondering why I do this. This sounds like a lot of work. And to be honest, it is a lot of work, or it was. we're now at a pretty good place, and it is working. It has been serving traffic since, well, a little over a year now. But the reality is that we did have sunk quite a significant chunk of engineering hours into this. So one of the things we really thought about, and I think Joe Bida does actually a really interesting talk on this, is sort of thinking about the separation of responsibilities from sort of the cluster operators versus the application operators. And we wanted, because we wanted to get to the you build it, you run it paradigm, we needed to give our application teams tools that will allow them to operate in a self-service manner and scale without needing to bother a centralized team for whenever they need something. On the other hand, our cluster operations team, or really us, we're responsible for making sure that there's always enough resources available, that the software we're running is the latest and greatest, upgrades, things like that. So that allows us to basically focus on different areas and allow us to sort of move quickly at the same time, which is really key for us. So, go ahead. Sure. Sure. So, yeah, so the question is, are we decoupling IT operation from application operations? And the answer is yes. Although we are both software engineering, or we are all software engineering teams. So I just like to think that we're operations-focused engineering team, which is, essentially the same. And then, so the decoupling of this is starting out, this was a big goal for us, but in retrospect, it hasn't really mattered. We started out by wanting to build an abstraction layer so that we could change the underlying implementation. Let's say Kubernetes didn't take off, we could go with Docker Swarm or Mesosphere, or Marathon rather, or Nomad. Turns out that didn't matter. Kubernetes has been pretty successful and continues to be the best-in-class offering in this area. So, but it is theoretically possible because we have an implementation-agnostic language. We could change the underlying implementation at any time if we wanted to, although it would be a lot of work, and I don't recommend that. And then lastly, I think the thing that we really set out to do is provide a sort of a magical user experience. So we saw what happened when we gave or forced every application engineering team use the same configuration management tools. The reality is people don't want to learn yet another set of tools to do their job. They already have enough on their plate as it is. And so we try to provide the minimum amount of new tooling for them to still keep being able to do their job successfully. And this has really proven to be, we've proven to be successful in this regard because we constantly hear feedback from people saying this is the best tool that they've worked with at DigitalOcean, and they're really happy about it. So I like to think that we succeeded in this regard, but who knows? I should probably do a survey or something on that. NPS. So in action, this is what it looks like. This is a little bit outdated view. We've actually shifted things around quite a bit since I took this listing. But essentially, you just run docc-help. It gives you a list of operations that you might imagine. Kubernetes has many of these. Many of the other tools in this space have similar set of commands. But anything that you need to get at around debugging your application, we have commands for. Sorry, not create, it's deploy. So docc deploy manifest.json, off you go. It'll push your application into the service, and which then pushes it into the cluster. And so roughly what it looks like component-wise, we have docc, which is the CLI tool. You as the user have a JSON manifest. We have a set of docc servers, which actually themselves run on top of Kubernetes as well, and are deployed with docc. Then those servers, actually what they do is they coordinate with external services that they bring into the cluster, as well as the Kube API server. So basically, you give it the manifest, which is this small, and then it turns it into like this many things in the YAML or JSON through the API, the Kubernetes API. And then on the other side, we have a set of controllers, ingresses, and third-party resources that all run within the cluster that are responsible for doing things such as, hey, there's a new service that needs an ingress. Let me create the ingress and then call out to our DNS, internal DNS, to actually make it available so that everyone can reach that service. Or, hey, I need to go get this certificate from Vault and make it available to this set of pods. So there's just a bunch of sort of It's just Kubernetes all the way down, basically, is what I'm, I guess, trying to get at. And so the responsibility of the service is just do the translation between our concepts to Kubernetes concepts, tracks the application. So we have a bunch of things that allow us to basically know what's deployed with Kubernetes, because we also have things that the cluster operations team deploys just using plain vanilla Kubernetes, because sometimes the platform can't support some of the needs of that, of what requirements of that service. So a good example of this is like maybe Prometheus, you need to give it a volume or something to keep some data around, or other things like that. So we have some exceptions there, but typically when an application gets deployed, we just annotate it in a way that we know who owns it, which service does it belong to, and a bunch of other things that I actually don't remember what they are now. And then finally it coordinates with external services to get pull things into the cluster and make them available from the cluster. So DNS is being a good example of that. And so at the end of it, what you get as an end user is, here's an example of a dashboard that is automatically generated for you. So when you use this tool, we grab your metrics from your pod, and we actually generate an automatic dashboard for you that shows you basic things like memory usage, CPU, network. There's probably other things that I'm forgetting now. But this is really nice because, like, if our operations team needs to look at an application, they know this dashboard looks exactly the same across all of them. We also track deploys in here, so you'll see like this little dotted line saying like, oh, there's a deploy, and maybe you'll see like the memory spikes up or file descriptors or something goes nuts, and you can just look at it and it's like, oh wow, okay, I guess we have a problem. So it's a pretty neat way to sort of have that available across all applications without doing any work. Are these metrics coming from Prometheus? Yes, they are. So we are very heavy users of Prometheus across DigitalOcean, and so for every cluster we have like a Prometheus that scrapes all the applications and makes it available in Grafana for the application owners. And then the other thing we do is we have we pull out your logs, or we allow you to expose your logs to our syslog, which then pipes them into a bunch of other systems and ultimately shows up here in Kibana. And then that's all done without you having to do anything other than write log lines, which is pretty neat. So these are all, the way we accomplish all of this is by having libraries that auto-configure themselves when they know they're deployed within the cluster. No, we're not using Plenty. We're using our syslog. Yeah. So we could talk a little bit about what is the impact of building a system like this, because again, it does sound like a lot of work, and it was. So far, all of our applications are now deployed with DOCC, which is pretty great. That has allowed us to grow from tens of services to hundreds of services very easily. Deployment is no longer the bottleneck. Like I mentioned before, we had instances where operationalizing a service might take more than a week. Now it takes closer to an hour, 2 hours. People can deploy software on their first day because it's so easy. We're averaging 25 deploys a day. I'm pretty sure that's no longer the case because we have a lot of automated CI systems also that deploy immediately. So we're probably in the hundreds right now. I'm seeing 75-minute apps per cluster. Probably not true either because we just had an explosion of applications being developed now that it's easier. So some of these numbers are pretty small, or pretty outdated, sorry. But you get the point. We're getting a lot of growth as a result of having deployment no longer being the bottleneck. But the key thing, as I've alluded to a few times, is that our development team is much happier. People are genuinely happy to be using a tool that gets out of their way and helps them do their job, rather than being an exercise in frustration where they have to spend a week using a set of tools that they really don't understand. Now, that being said, there are still instances where we run into rough edges with Kubernetes, or we find problems with Docker or other things, or sometimes our own software. That does happen, and that does frustrate. But because we have a team that's dedicated to that effort, we're very quick and able to sort of track those problems down and get them addressed. Whereas and the teams that are using this feel like they actually have someone supporting them, rather than before where it's like, choose your own adventure, you go figure it out, good luck. So that's a big change in our culture, in our engineering organization, and I think that's been really positive, has had a really positive impact. I'll leave you with this quote from a coworker of ours. So the point of this was to reduce the developer decision fatigue so that the developers can make decisions that matter. And I added to the business because, that's important. So yeah, it removes a set of things that people used to worry about and allows them to actually just focus on building software. Thank you. And do we want to do questions now or after? Okay, go ahead. Mm-hmm. Yes. What is the DOCC service written in? It's written in Go. So we are very heavy users of Go internally. Fairly early adopters, I suppose, and it just so happened that, that may or may not have also influenced our decision to go with Kubernetes because we're like, we can actually understand what's going on here. So yeah, we're using Go. How would we? Yeah, so that's a great question. How would we compare this to Helm? I've been trying to formulate my thoughts on this for a while. I think I need to get more familiar with Helm to actually be able to answer that, to be honest. I think Helm has a lot of the same ideas, but we have a little bit different approach to them. Have we looked at other? Yes. Yes, we have. Yes. So we've looked at both similar solutions in things like such as days for workflow and OpenShift Origin, is it, or OpenShift? Just we looked at both of those, but ultimately what we decided on is the fact that we have a system that's fairly unique to our environment, and so it made sense for us to build a customized platform that integrates well with our environment. Yes, this is yes. So this is an internal only tool for DigitalOcean. I wish I could give it to everyone else, but it wouldn't make sense. Yeah, yeah, it wouldn't make sense. And if you do want something similar, I would definitely recommend looking at OpenShift and Days Workflow. They're both fantastic tools in this space. Sorry, go ahead.
Do you have any abstractions on multi-data center?
Sure. Do we have any abstractions on multi-data center? Not yet. We do allow people to deploy this at the same time to multiple instances, so multiple clusters at the same time, and that does happen in sort of a lockstep. But there isn't any federation. We haven't integrated any kind of federation or things like that. That is still semi-manual process for the time being. Yeah, but we're absolutely looking and keeping a close eye on federation. It seems interesting. And because we do have applications that run actually globally, so in every site data center, you can imagine many of the data center control plane applications are things that actually have to run everywhere. So it would definitely make some teams' lives easier by having like a global option to just deploy to every data center, or maybe it's just a small subset of data centers. But that's not something we have available today. Go ahead. Yeah. Mm-hmm. Yeah. So have we looked at stateful things? Yes, we have, and I think we have a sort of a cycle of every 2 months or so, maybe every month we have a guy who goes and looks at it and is like, oh, it's not ready yet. All right, let's come back to it later. And so he's been doing that for a year now or so. But we're absolutely keeping a close eye on that. I think that landscape has evolved significantly over the past 6 to 12 months. Yeah. So it's very exciting and interesting. I think I'm certain that that's going to be possible, and we certainly hope so. It'd be fantastic if we could move some of the more stateful workloads over to this as well, but we haven't felt comfortable doing so yet. Go ahead. Where are we storing? Sure. Yeah. So where are we running our data stores? We have the same traditional set of tooling that we had before we embarked on this journey. We still have that tooling available, and we have made some improvements to make it easier to manage data stores, because that is currently the primary use of that set of tooling is to manage data stores. So data stores are managed with more traditional configuration management based tools, which is not ideal, but it gets the job done well enough. And we have invested in that over the past few years to get it to a point where it's not the blocker for the most part. Yeah. Uh, yeah, your guess is as good as mine. I don't want to name any names. We all know that's yeah. I mean, listen, DigitalOcean is at a point where we have literally everything under the sun in our organization. So we have probably 4 or 5 CI systems. We probably have 4 or 5 configuration management systems. We may have even invented 1 or 2 of those, or 1 or 2 of our own rather. So yeah, we have a lot of systems, unfortunately. And this is hopefully a step towards actually getting us sort of fanning in rather than fanning out. So actually shedding some of those old tools. Go ahead. Mm-hmm. Mm-hmm. So would it be fair to summarize your questions like how have you found the experience of working with upstream Kubernetes and whether you've been able to contribute back or whether there's been issues? Um, Challenges and opportunities. Yeah, I would say given how large the Kubernetes community is, most great ideas that we've ever had have already either come from the community or have been already available in the community, and we're just kind of happen to come to the same conclusion. Literally every time I go to open up a ticket or do something, it's like, oh, somebody already has something out open, so it's fine. I think the biggest frustrations that we've had with working with Kubernetes or challenges, uh, well, when the Go API client was in the Kubernetes core repository itself, and that was pretty frustrating because like vendoring that Kubernetes itself is not a small feat, especially because we do monorepo based development, so we have all of our code is in a single repository, and so vendoring Kubernetes would bring in a lot of conflicting dependencies on other systems that we've already rendered. I think one of the biggest takeaways for me looking back is if you're going to do something like this, invest heavily in the tooling to maintain and manage your clusters. Early on, we didn't really spend a lot of time on that because we just wanted to get something quickly out the door. We were more focused on the actual providing the service than actually helping ourselves run the service. And so we had some growing pains around that as we've been evolving. Because one of the things about Kubernetes is it does move fast. Like for a piece of software that it is, it does move really fast. So you'd be surprised how easy it is to lose track of that. And being sort of the kind of being a cloud provider that we are, we don't have the same luxury as some of the other folks, our customers necessarily have, which is just destroying an instance and spinning up a new one. We don't always have that luxury. So sometimes upgrade process can be a little bit painful, and so it's really worthwhile to think that through. I think that's probably one of the things I wish we had spent a little bit more time up front thinking about. Now that I'm looking back at it, so yeah, cool. Oh, did we build our own tooling? So the answer is a little bit of both. We've certainly adopted some community tooling. I don't think we use any of the upstream Kubernetes focused tools. We actually use non-Kubernetes tools to manage our clusters, which is a little bit strange. But we found that there's actually a fairly good amount of tooling out there that actually allows us to manage the clusters fairly easily. So we certainly hope that we can bring in more of the tooling in the community. One of the things I really like about Kubernetes is the community and the ecosystem around it. It's amazing what you can get. We're all really standing on the shoulders of giants. Things move so fast and problems get solved all the time for us for free, and that's really amazing. What version are we on? So we are on a number of versions right now. I think we're yeah, not quite all of them, but yeah. we have a few versions. We're in the process of actually upgrading to the latest version. We just had a hiccup more not around Kubernetes, but actually some of the underlying dependencies that we were depending on, and so we had some issues around upgrading those in a sane way, and so we just needed to spend more time on the operations side. And this comes back to sort of what I was saying before about invest into your tooling. Yeah, make sure that's a normal process because it will happen often, right? You could almost weekly upgrade your Kubernetes clusters, and we're certainly seeing a lot of great progress being made in that space. So, yeah, cool. Well, I'll be around if you want to ask any questions, but I think we should keep moving. Yeah, no. Yeah. I thank you.
There's more beer in the fridge.
It's the same thing. When you see my stack, that statement will ring true. Get everybody settled. I don't have a whole lot of time to fill, so it actually worked out. And plus, I kind of wanted to concede some of my time to both of the conversations tonight anyway, because I found them way more interesting than mine. So my name's Ryan Cooke. I currently work at Sauce Labs. Before that, I worked at a company called Athlinks here out of Louisville, helping build out their containerized infrastructure, and I've moved on to Sauce to do the same there. This isn't much about anything that we're doing at Sauce, although we are using Kubernetes there. It's mostly I've kind of existed in this space for quite a while now, and I didn't necessarily exist in the space out of blessing for any current employer at the time. So kind of had to figure out creative ways to spin up what I wanted to do and test and be able to test actual HA solutions, not just like Minikube on my machine or at the time Docker. Back when I started getting into this, I've existed in cloud providers for I think probably about 4 years now, and it's really easy to spend other people's money, but once I got the first bill for my own stuff, I didn't enjoy it so much. So those are just some kind of tips and kind of what I'm doing for my own stack, quote unquote. It doesn't deserve that title, at home, and some ways I found to cut corners on cost. can be relevant for your own personal pet projects, but also if you're trying to get something started at a company who doesn't necessarily want to or has a very small budget, it could be helpful. So why this stuff tends to be my hobby, as sad as an admission that is. This is what I do for fun and work. I'm testing stuff constantly. I have a plethora of pet projects because I have ADD going on at all points in time that I need to be able to test. And I don't like building things that I couldn't ship to production in a day if I inevitably had to. I said inevitably like that's never going to happen, but I try to build my things with those things in mind. Also, I really, really hate paying for things. So that's kind of why I've tackled the things the way I do. Like I said, the benefits, it converts really well in the end to a real world deployment. Just change the number of instances of what you're wanting to run. Really great for testing distributed systems, any stream processing systems, and like Kafka, or doing any sort of things with Spark or Hadoop is really beneficial there. Because everyone can run one instance on their local machine, but that doesn't necessarily translate to production. So you can easily ship your POC in the end. So kind of how very first and foremost, the basics. Anybody familiar with containers know to keep your image sizes as small as possible, which is really easy to say from a purist perspective, but there's actual benefits there. Keep your image sizes small. Do not run any build dependencies in your runtime container if at all possible. Sometimes it's unavoidable. Share your layers properly. For example, if you have an application that's dependent on Java, so a lot of the last place I worked at Athlinks, most of our stuff was Java based, or at least dependent on the JVM in some way, shape, or form. And it's easy to fall in the trap of running literally everything in one run command, but that's not always best practice. For instance, if you're installing Java in the same run command as your application, you're reshipping Java every single time that you're shipping your application. This makes for slow deployment times, makes for unnecessary storage, be it on the registry, on your physical host that it's going to land on. But if you are paying for a registry and not running your own Docker registry, that your biggest expense will be there because you're transmitting a lot of unnecessary data. And if you're using things like the Google Cloud's registry, you pay per the bandwidth that you use. So that's pretty low-hanging fruit. Combine like commands into one run. So for instance, use from your Java image that you share across your entire stack or your Java 8 or 9 or 7, what images, and then try to keep all of your like commands in one run. Like I said, it will decrease your data transfer, but also there's stability improvements there in the event of failure. If you were to say lose a node, you more quickly recover from that time because there's not as much time to pull down a layer because your image sizes are smaller. So just an example of keeping all of your run commands like commands in one run. Reason being, as most of you know, Docker is a pinned-only file system. So if you were to install dependencies in one step and then remove them in the next one, although they're marked as deleted, your image size still grew. So here you can see that I'm installing curl, which I need to pull down the Hugo image and then immediately removing them in the same step. Other big point, use Alpine or Scratch where you can for sure. It starts you up, I think the Ubuntu image, which is used for a lot of things, starts at what is it, 85 megs, somewhere around there. Has it shrunk any? Alpine starts at 5, so you save a considerable amount there. Another tip is to use cheap or free services. Seems obvious, but the thing that I've learned when rapidly iterating over my stack. I use my my cluster at home kind of as a test bed. So at Sauce, we do run on bare metal. I was in easy mode at Athlinks before that. I realize now having a cloud provider to do everything was considerably easier than metal. So I use my stack at home at least as kind of an alpha test bed to work on some things that I'm trying out. So I've had to strip out things that I want to exist when I'm working on it still. Out of that, like I used to run a GitLab system on my machines at home. Used to run my own registry. I did run Deis for a long time, but it became problematic when I was, or not necessarily problematic, but it required a lot of extra time to get those services back. At least the ones that I wanted to maintain state, such as my source code, after I would take it down and bring it back, because I do it typically around once or twice a day. If I'm testing really low-level stuff like networking or Calico or Flannel, switching back and forth to see performance increases. Also, that frees up resources in your cluster for things that you want to test. So if you're doing things like me and testing some Spark jobs, for instance, I need as much raw compute in my cluster as I can get. So having that overhead removed out of my cluster frees up a lot of more resources for me to test things. Also, Let's Encrypt has definitely been a godsend here as far as me spending money. I used to pay for a wildcard for my test domain every year, and I just got to let that lapse, and I'm really, really happy with that. This one's mostly an affirmation for me because I'm really bad about it. Large scale not needed on your dev cluster. Keep your resource limits low. A lot of instances I've actually stripped out just because it's a dev environment and I want to be able to test more services, and their stability sometimes matter locally, other times they don't. I'm just trying to prove something out. In the instance that I'm just trying to prove something out and I need to be able to stack more services on my host, I just completely remove the requests in the resource limits out. So it will allow me to over provision the crap out of my stack. I don't suggest that at all in a production environment, but if you're doing things like testing things that require quorum, use 3 instead of 100. Or if you're using something that doesn't require quorum and you just need to know if they'll they'll operate in a cluster at all, run them at 2. You don't need to run 100 instances of them locally. You can, but you're going to waste a lot of your resources. Test that it scales, then scale it back down. And most importantly, clean up after yourself. So, other thing, run on metal. So this is the stack, quote unquote, at my house. It is all of my own old hardware, which I've just revived as a Kubernetes cluster. So I'm running Ubuntu on them now. I think I'm going to kick them back over to CoreOS pretty soon. Running Calico as the networking stack and using Cargo to spin them up because it's really handy. We're an Ansible shop at Sauce Labs, so it matches really well to the rest of our configuration management, and it was a really easy sell to the rest of the team. So proofed it out here, and now we're running it in Sauce. Funny story, this one just got added to the stack maybe a week or 2 ago. I was letting my son use it to play Minecraft. He's 6. And he hadn't touched it for about 6 months, so I figured it was free. Yeah, it was a free game. And yesterday, I got to have a fun conversation with my son as to why Dad needed to add more capacity to his Kubernetes cluster, and why he doesn't get to play it anymore. What was that? So right now, as far as persistence, the only thing I have is this old box right here because it can fit hard drives. The others can't. Their old laptops can't really well. Yeah, the printer. I used to work for HP. I got it as a freebie. Don't judge me. That I just run an NFS share out of for basic persistence. I definitely don't suggest that if you need any sort of high I/O, but in a pinch it works. Pretty soon, hopefully, I've got to go. I've been playing with Rook a little bit and using the dynamic provisioner for that, which has been really handy. But if you need to do any block level storage, you have to set up a dedicated disk to that. So I've got to go re-image all of them and set up a separate partition for it to be able to use for that. So I'm not using it in practice yet. I've used the what's the file share version, so Rook is just Ceph wrapped in by a lot of nice stuff done by CoreOS. I've used the file share, but I haven't used the block storage yet. So yeah. That's the Glacier. All of my logs, once they've been 30 days, they roll off to the printer. So that being said, my current tooling of choice, a lot of GitLab.com specifically. So I've been a GitLab user for probably about 5 or 6 years, since way back in the day. But the offerings that they're doing now for like GitLab.com, you cannot compete with as far as getting stuff for free. So obviously free unlimited private repos. Their CI is pretty awesome. And also, it's not very well advertised, but I found it one day and that hasn't stopped working yet. You get free unlimited storage for containers too. So all of my images are through there. That being said, I don't plan on that lasting. So if you're choosing a bunch of free resources, make sure that you can easily swap them out. Don't back yourself into a corner. I don't think free containers storage for life is going to be a thing, but for now it's working great. Using Cargo for the bare metal installs and getting Kubernetes up and running, it's incredibly simple. If you're familiar with Ansible, there's 3 different groups in your inventory. You say, here's my etcd, here's my masters, and here's my workers. Any combination of those, you can add your hosts, point it at the IP address of your physical node, runs the Ansible scripts, and you have a Kubernetes cluster. Also works it's idempotent, so it works really great to swap out. So we're currently at Sauce working on a conversion from Flannel to Calico. So I've been testing out safe ways to roll that forward, or at least cut over to a different cluster for a short time, upgrade in place, and cut back. Cargo's been really awesome. You just change it to there's one variable in your variables file, and you just tell it to use Calico instead of Flannel, and vice versa. Rerun, and it swaps them out. Calico, if y'all are familiar with at all, is a networking provider for Kubernetes, which I'm pretty fond of. I just cut to it and cut literally, I think it was 75% off of our response times, just from the way it handles routing rather than going through the proxy. Helm has been integral here. So, like I said earlier, clean up after yourself. Helm is really awesome in that regard. Makes it easy to turn it essentially into one giant package, install it, deploy it whenever you're ready, and then tear it down when you're done. Cleans up after itself really nicely. And then Traffic, which I use as my ingress here, which I'll show you guys in a demo in just a second, has been awesome. It has native Kubernetes support and will use the service mechanism in Kubernetes to detect pods on the back end, but rather than routing through the kube proxy or the service proxy, uses the service to figure out where those pods are and routes directly to them from the ingress. So it's pretty handy. And it also warm reloads those in, and has, if you're like me and cheap, has Let's Encrypt support out of the box. So I just create an ingress manifest for my service. Says it's test.example.com. If it doesn't exist, loads that into the back end. Once that comes up, it does the Let's Encrypt verification. So it'll just temporarily intercept the traffic as long as your DNS is pointed at it, run the authentication, and then once the authentication's done, it pulls itself out of the way and points to your backend. So kind of putting it all together. So right now, if I go to, let's see, demo. So this is just my test domain that I use for everything. I thought it was really cool when I was younger, and I just held on to it. So there's nothing there yet. We're just going to deploy from scratch. Other really cool thing that I like about GitLab is it ties its issue board, which is similar to like a Trello board. It's just Kanban board. Ties that all into the mix really well, so you can associate an issue to a pull request, to a deployment, to a physical environment, and then back the other way. So you could go to your production environment and say, this is this commit, is this issue, and it really makes for really nice tracking throughout. So I have just a really simple Node.js app, which is just the Node.js getting started from Heroku, and use that, and just a basic Docker file, a K8s chart, which I can show you what's in here, or a Helm chart. All of my things, so this is pretty much a boilerplate what I use. I just copy this directory into everything. Now Draft does that all for me, but I haven't got to go refactor all my stuff to it yet, because this was done before you guys released that. But have an autoscaler, a deployment, and then here's the ingress, which just detects in my values file. I'm using domain routing here instead of path, but let's see. Pretty boilerplate. And then I also have a config for my different environments. So my dev is demodev.stratospire.com. Excuse me. So I submitted a merge request earlier, so in my GitLab file, all I'm doing is a Docker build, a test, which just essentially spins it up, make sure it answers a curl. And then once it's released, accepted to master, it will push the image and then deploy. So it'll auto deploy to dev, and then I have a manual step for production. So let's see, merge request. This is not a whip. Merge. Woo. So this just kicks off a pipeline. It's going to do the, going to run my test for me. I forgot to tell it not to do that on master, but cool. So that's completed, and I'll move on to release, which pushes it to the registry. And in a second, let's do. As soon as that push finishes, it'll do a Helm release. Come on, demo gods. Cool. So there we go. Let's see it spinning up. It's in a replica set, or it's in a deployment with a replica set of 2, and then in a horizontal pod autoscaler. So if I put it under load, you'd see it span out. But so it's waiting for them to pass their health check. While that's happening, So here's the dashboard for traffic. Let's see, demo dev. You can see that it's detected the one that's ready in the back end. And as soon as this one goes available at some point, there we go. It detected it in the back end, so now this should function. And it did its let's encrypt. So yeah, that's it done through GitLab. Let's see. We'll do straight to master just for the hell of it. So yeah, you can see everything that's running on the back end. Also through GitLab. You can see here there's two ways that I could take this to prod. It essentially does a hold step here where I could tell it to deploy to prod, which is handy if you know what your release is. I know at Athlinks the POs got a lot of value out of this by knowing just say this is the thing that's in stage now and I need to take that production. So you can actually go see what's running in each environment, and rather than saying, I know this is my commit here, you can just go find dev or stage prod, whatever, how many environments you have, and then say, take this, what is in this environment to production. You'll also see that kick off a demo prod. So it's going through it. So right now it's being intercepted by traffic. So it takes roughly 10 to 15 seconds for it to happen the first time. And then the renewals, I've noticed, will kick over for maybe, so let's encrypt expire every 90 days, I think is what it is. This still handles the auto renewals for you. It'll intercept traffic for about 5 seconds. So not acceptable in all production environments for sure. There you go. Cool. That's it for demo. So my favorite part, questions? None? Okay. So I have metrics running on my hosts from outside world in, essentially just typical your response times kind of metrics. And so there's more backstory to it than that. So in my home lab, I have those running. First initial test cut the response times by about 75%, but there's reasons as to why it handles it a little differently. But the other reason that we're going is we are solely bare metal at Sauce and an actual data center, and we have an actual networking team who we would actually like to be involved in that whole process. And for obvious reasons, they like Calico. It's not an overlay per se. Yeah, short answer. Any other questions? Cool. Thank you, guys.
Do people want to take a real quick break and then discuss the draft? I think that's a yes. People are voting with their feet. Let's take 5 or so minutes and then we'll get going with draft. Restrooms are down. Yeah. Right by the elevator. Hey, I'm Scott.
Ryan. Thank you.
So I'm actually no close friends with your CEO, Charles Ramsey.
Oh, yeah.
Yeah, I worked
Nice.
with him about 15 years ago.
Nice. I've been there
3 months, 4 months. I was looking at
2 months, 3 months. I don't know. It's gone. It's been crazy.
I worked with Ramsey when he was at a startup.
All right, Gabe. All right, so last this evening, the Kubernetes Colorado June meetup. Matt Tucker is going to talk about draft. Matt is a multitasker. He was doing the recording while we've been sitting here, and one of the main things he works on is draft, which is a new tool Microsoft just released. And take it away.
Cool. So yeah, draft kind of started with the goal of streamlining Kubernetes development. We think it's way too hard to get simple things out to a Kubernetes cluster, and you have to know way too much. Even knowing what Docker is and what a container is, what a Helm chart is, what a deployment, a service, an ingress, all these different things you have to understand in order to deploy your application to Kubernetes. And this kind of, in a way, kind of sucks. It should be a lot easier. So draft was kind of an idea that started started as an internal project at Deis, and it's built on top of Helm, which you've kind of heard thrown around a little bit today. Who does not know what Helm is? Cool. So we got at least one hand. Helm is basically a package manager for Kubernetes. It allows you to, a single application deployed to Kube requires a number of different manifest files, resources, services, ingress, probably up to maybe a dozen of these different YAML files. And there's no easy way to kind of package these things up as a single deployable unit. That is what Helm does. In the end, it does a very simple job, but it does it very, very well. If I take a quick look at the Kubernetes charts repo, so first of all, Helm and Draft are both completely open source. Helm is contributed to the CNCF and upstream in the Kubernetes GitHub organization. If I look at the Kubernetes charts repo, this is where all of the user-contributed applications and charts have been pushed up to. So if I just dig into the stable branch, man, there's new things here every day. Basically any and every application that you want to deploy, there's probably somebody that has created a chart for it. So if I want to install WordPress, or I want to install Console, or Influx, or MongoDB, or Linkerd, or whatever it might be, you can just Helm install whatever it is you want to install, and it'll be deployed on your cluster. So Draft takes that a little bit further. The thing that Helm doesn't do is help you kind of build the Docker file and manage the deployment of this entire application up to your cluster. So instead of talking more, I'm just going to show this, because in the end, that's the easiest way. So right here I have VS Code with a really simple Python application. Hopefully that's all big enough there. My fonts are a little bit weird. So I have a really simple Python application that imports Flask, and from the requirements.txt it imports Flask, and then just has a simple hello world route. In the end, all I have to do is run a command called draft create. Draft create basically detects what type of application, and look, here's that I already ran this. I meant to do this over here. If I run draft create, it will detect the type of application. In this case, it sees that it's Python, and it says we're ready to sail. What that means is that it basically injected in a Docker file, a chart, and then a draft.toml file, just the configurations for this particular draft. If I just glance at the Docker file, we'll see that it's a really simple Python on build container. Yes, this is not the ideal way to do these things, but it is completely flexible. You can use whatever Docker file you want, whatever build process you want, and in fact today, thanks to Aaron's PR that was merged, you can even use multi-stage Docker builds, and that all works. And so there's some new stuff that's kind of awesome there. I will get rid of my sidebar here because we know that this is really a simple application. So once I run draft create, I can now run draft up. Draft up basically pushes the entire working directory's context up into the kube cluster. From there, a process called draft D running on the server builds the Docker file, pushes that to a registry. That registry, with upcoming PR, can be an internal registry if you're running Minikube, which is awesome. In this case, I'm pushing to an external registry just out of ease. But in the end, you'll notice that it says status deployed, and hey, you can go here to access your application. So that's kind of awesome. Let's refresh that page, hopefully. Oh, come on. Come on, demo. You can do it. Oh, wow. Oh, wow. So we're going to just take a quick look, see if I can guess what's going on here. Why did we just fail? Yeah, this would be all right. I will just push forward with the demo in a way that I know it will work. Cool. So I also have this really awesome thing set up, which I highly recommend people doing, which is routing my DNS traffic through my Minikube cluster, so that any service that I deploy to my Minikube cluster, I can just hit locally, which is just awesome. So instead of going through the ingress, which apparently there was a weird problem there, I'm just hitting this service directly. I'm just going to start a little refresh loop on this, just because that makes the demo a little bit cooler. Come on, shrink the size here. So you'll notice that the other thing draft does is it starts watching the file for local changes. This is pretty awesome because I can just go, hello, Kubernetes, Colorado, press save. And the instant I do that, draft notices that that file changed and starts building the new Docker image with that change. And essentially doing what was just demoed of this entire pipeline done through GitLab, but instead this is all happening right in our cluster. And if all goes well here, with a couple refreshes, there we go, we see that that change has been deployed. In the end, it is that simple. Right now we have support, as of today, we have support for 7 draft packs. A draft pack is essentially just a Docker file plus a Helm chart, and that's pretty much it. Besides that, it does have a little detect script. And in fact, I'll just go show one of these. So if I cd into .draft packs, we'll see I do not have the latest and greatest, but there is now a .NET pack, if you so desire. But if I just go inside the Python, we'll see that there is the Docker file, the chart, and a detect script. The detect script is ridiculously simple. In this case, it just looks for requirements.txt or a setup.py or a pip file. This is essentially the exact same logic that Heroku uses for detecting the type of application. And in fact, we are bringing in Heroku's license because we pulled these directly from them. And this works for all these type of applications. So Draft itself comes with several example applications. So we have basically all the examples for all these applications. If I just take a look at the Golang, for example, just a very simple, hello world, I'm Golang serving on 8080, and the chart is no different. Oh, I would have to actually run draft create here, wouldn't I? So we'll see that it detected a Go app, and if I go into this chart, there's nothing too complicated here, basically exactly what you'd expect. Whoa. Just a deployment, an ingress, and a service. So there's nothing fancy here. In the end, it is very, very simple, and man, my prompt does weird at this size. Can't really stand it. Please. The notes file, right? It is. It's basically part of the pack is the notes file, and that's correct. So when you go to install draft, I can't really show that because it would give away credentials. But when you go to configure draft, I could bring it up here. Installation guide, where are you? There we go. So when you go to configure it, and this is also very soon about to change and get a lot easier and more awesome. But right now, when you go to configure it, you run draft init, and you basically pass it the credentials to your registry in this really ugly format. In the future, this will basically read your Docker config file and determine and ask you, like, hey, you have these registries configured. Which registry do you want to configure with draft? And it just will handle it all for you. And then a part of that at the very end, which is hanging off my screen here, is the base domain. And so draft does require that you set up a wildcard base domain. And so that's the part that for some reason broke in between me moving from there to here, is that I have a wildcard.minikube set up that routes directly to my Minikube's ingress controller. And so that's basically what I configured for my base domain. But if this is deployed onto the cloud, I would set up a star.draft.example.com pointing to my ingress. And then all applications based on Helm's lovely naming. For those of you that have never used Helm, it likes to pick random names like it did for us. What did we get here? Sweet Seal. So it basically ends up at the release name dot your wildcard domain that you configured to draft. And so all of that just works. There's honestly not much more to it. It is that simple. I could definitely go into some more details. Oh no, this is VS Code. But if I wanted to, I could just what's that? Sure. Azure Draft Examples Python VI app. How did I get in Visual Block? And if I come back over, you'll notice that it's already rebuilding. And this, I could have run this command in a normal terminal. I just like the integrated terminal of VS Code because it all is right there, and I can close it and bring it back, and it's still watching and all that stuff. So it's pretty handy. Yeah. Right. In the end, it's completely up to you, and that's kind of the part that I could go into. Is just we built draft as a completely flexible system. You can have all your own draft facts with your own detect scripts and your own logic for determining which draft fact to use. It's in the end, draft is pretty. I hate to say that it's pretty dumb, but it is. It just goes through all the packs in your home directory, loops through those detect scripts, and the first one that returns true is the one that it uses. And so you can pretty much determine which pack is going to be used. Right, and that's definitely some of our future kind of ideas of how draft might be used, especially in like an enterprise setting, is people that have certain standards for deploying applications can basically encode those standards into their own draft pack, their own Docker file, their own chart. And these things can be used across the entire organization very, very easily. Draft basically relies on Helm for this particular step, for actually managing the rollout of, and in fact, if I just do a Helm list, we will see, there we go, Sweet Seal, and we will see that it's on revision number 7, because I've done a few tests here, but in the end, it's relying solely on Helm. Correct. Part of the draft.toml file. If I pull that up, basically that's where the name gets slammed in. Whenever I run draft create, it determines the type of application and Helm assigns it a name, and we slam it into the draft.toml file. But yeah, it's interesting. I would like to know a little bit more details about what. Helm really, I mean, that in that sense, that's a Kubernetes thing, and Kubernetes really shouldn't do that. Okay. Right, right. No, I'd have to dig into the specific problem a little bit more. In the end, it just does standard rolling deploys, standard updates to resources, and lets Kubernetes handle how that rollout happens. Yeah.
This is awesome. I use this tomorrow to deploy my stuff in production.
Yeah. Draft, as the name kind of implies, was never intended to be used as a production deployment tool. We anticipate it being used with processes similar to what was just shown with GitLab, or we have very similar demos using Jenkins and other things. We anticipate that the production deployment would go through an official pipeline like that. In the end, draft, the idea is solely for a developer hacking on code, cranking things out, wants to see how it might look in a Kubernetes cluster. Awesome. Yeah, it's definitely something, there is an open issue out there about whether or not draft should manage Jenkins files or GitLab files or whatever. And you could absolutely add these to your packs internally without any problem and take advantage of all these things. We, as a project, don't really know how much we should prescribe via our examples, and so that's kind of why we kept it as simple as we possibly could. But as we mentioned, the packs themselves right now are just the Docker file and the chart. You can throw any number of files in there, and draft will basically just slam those into your directory when you run draft create. We do have some lovely draft mugs. If you want to grab one on your way out, feel free. But yeah, it's definitely a fun little project, and we were kind of blown away with how quickly this star number jumped up there. It's obviously filling a niche that people kind of want something like this, and we kept it simple from the beginning by design, and are definitely looking for feedback to improve it. Yeah. Absolutely. There is a video just right here on the README that it's essentially just what I went through right here, just showing an example of how this is done. But there's a couple other really detailed blog posts of how to install this onto Azure Container Service or onto Google Container Registry or Google's Cloud. There's plenty of people that have written blog posts about how to actually get this out there. And I definitely am really, really looking forward to this one right here, because it solves all the complexity of getting this up and running. It probably is the hardest part. If you go try to use this tonight or tomorrow or something, pay very close attention to the documentation. Creating the exact draft init command to pass your registry authentication credentials is a little bit tedious today, but this PR will hopefully land here pretty soon. And in the end, it is no. I'll simplify it that way. It's being rewritten a little bit to use gRPC, so there will be a gRPC API, and you can interact with it directly with the Golang library. But in the end, I probably wouldn't, just because we are on 0.4 right now. We're in no way going to hold that API. It's going to change. but yeah, I think that's just about it. I